Alright, I'm going to show the 5 time value of money functions to solve problems. And to do that, I've got a question right here. I've got the inputs as they would be here. And I'm going to put the function I'm going to use, what the function solution would be, and then what the answer to the question is over there. So $7,000 earns 5% interest. How much is there in 9 years? So I've got 9 years, 5% interest, and $7,000 is the present value, and I want to find out what the future value is. So the solution would be equals FV, open the parenthesis, the interest rate, the number of periods, the payment. There isn't one. I'm just going to skip it, kind of, but I put in this blank, and then present value is 7,000. So the future value shows up to be minus 10,859 minus 30, which is not can be the correct answer. It would be 10,859.30. That's what it's going to grow to at that point. Here's a second question to do with that. So a payment stream of $3,000 each year. So it's a stream of money. With the first payment coming in 1 year, okay, will last for 6 years. And the discount rate is 11%. How much is this payment stream worth? Imagine this would mean today. So I'm going to be looking for a present value. This function, present value. So solution is present value, the interest rate, the number of periods, the payment, and I get minus 12,691.61 from the function. But I know the answer is how much this would be worth. Would be the negative of that, 12,691.61. It's a positive number. Following along, we have a really similar question. So from the previous question, suppose the first of the 6 payments comes immediately. What is the value of the payment stream? So I'm going to keep all of this information, paste it in there. But if the first payment comes immediately, this makes it an annuity due. So I'm going to put a 1 here for the annuity due. This is still a present value function, and the solution is going to work the same way for the most part. Present value, the interest rate, the number of periods, the payment, and I need to get to type, not just FV. So in order to get all the way to type, I'm going to have to go through future values. So I'm going to put that in, it's in a blank, so it's going to be a 0, and then annuity due, because it comes at the end of the year, sorry, at the beginning instead of the end, it's 1 instead of 0. Alright, and it shows a minus 14,009, almost $14,088 would be the answer to the question. And so the annuity due is taken care of by putting a 1 at the very end. Alright, for this next question with the loan, $100,000 and $8 monthly payments, this is the first time I've got 2 dollar amounts, so I'm going to have to be a little more careful about how I work the information here. But I was asking for the interest rate, so my function is going to be rate, and I'm going to put in all the information that I know. I don't know the interest rate. I know that there's 15 years. You see how this heading has years of monthly payments, so my compounds per year is 12, and monthly payment is going to be 800. Loan is 100,000. So loan starts off up front, where the borrower receives 100,000 and then makes payments of 800. So 800 leaves the hands of the borrower every month, so that one's negative, and they received 100,000 for the loan at the beginning, so that's why that's 100,000 and that's positive. Okay, so the function is rate, so I'm going to do equals rate, open the parentheses, number of periods is B5 times G5, that would be 15 times 12. The payment is C5, and the present value is D5. Now I don't need to enter in the future value being 0 and so forth, so I can leave that alone. Alright, and I get 0.43%. However, that's not the answer to this question. That's just what the monthly rate is. That's all that's going to be able to solve out of that. So to get the correct answer, I need to take that number and then multiply it by the number of compounds per year, 12. So the answer to the question is 5.18%. All right, time for the next question. So we're going to make payments of $700 and want to find out how long it's going to take to repay the loan in this case. So the interest rate is 7.2%. How long is it going to take? The function is number of periods. It's actually asking for it in years. And I've got monthly payments. I've got to make the future value turn out to be 0. I'm going to type it in this time. Present value is 100,000. Oops. And monthly payment is 700. So 700 leaves hands of the borrower every month. How long? I don't know the number of years, but the interest rate is 7.2%. I'm going to just to show you that you could use numbers straight into here instead of the cell references. I'm going to use just the numbers for this. Number of periods. Well, the interest rate is 7.2%. I can divide that by 12. The payment minus 700. 700 is leaving the hands of the borrower after they receive 100,000 up front, and they pay it all off. So this is the number of periods would be 325.29. That would be the number of months. So to get the correct answer in years, I would have to take the number of months and then divide it by 12. Okay, so you could use numbers instead of cell references, which is what we have done in the past, and I'll go back to it from this. Just want to show you that you can type in numbers. In this case, I could delete off all this work and nothing would change. But if I delete off this, then it's unable to do the question. One of the nice things about using these numbers is that I'm showing explicitly what I'm doing, and I can change one of those numbers and then see what the effect is. Another thing that you might want to consider on this is 27.11 years. If you're curious as to what it would be in months, you can go to Home, Number, and then go to this custom number format and write 0 to show me, well, it's 27, and I'm going to ask it to show me in months beyond that. So it's 0, and if I use 0 or number, it'll tell me the number would be, so 27, see the sample there, 27 years, and 1 out of 12 months would be the answer too. It's just another way to show it. It doesn't change what the number actually is. That's just rounding this, the number that it would have been, to the nearest 12th. Alright, for more practice and entering these in correctly, we have a very simple question. Balance. What is the balance on this loan after making payments of $700 for 10 years? So I've got monthly payments. I've got an interest rate of 7.2%. I've got 10 years. The payments leaving the borrower's hand is 700, and the amount they received initially is 100,000. And so we're looking for the future value. So the future value would be, well, the interest rate, 12 would have worked, by the way, just to be consistent though. It's the compounds per year. Number of periods is the number of years multiplied by number of periods per year. The payment and the present value. And I can close this off. So it says the future value is minus 82,500 roughly. So I know that the answer to this question is actually a positive 82,500. So 10 years of making payments of $700, and you've only knocked off some $17,500 off of the initial loan amount. You pay the whole thing off in 27 years, but the first 10 years you don't pay very much off. Alright, the last questions can use the last of these functions to use. If you look up above, you will note that the only one we haven't used is payment. Actually, to make it so that I can see this top line, no matter how far I scroll, I'm going to go right below the top line and go to View, Freeze Payments. Now, no matter how far down I go, I get that top line. So you can see what I'm working with. Okay, monthly payments. So still got 12 there. Required to reduce the balance of a loan of $100,000. So I'm starting with $100,000 and reduce it to $40,000. Okay, if I'm reduce it to $40,000, that would mean it would take another $40,000 to pay it off. So that means it is negative. I don't know the payment. Interest rate is 7.2% annually, and I'm looking at 13 years in. Okay, so how much would it take of an annuity or a monthly payment to pay off $60,000 off a $100,000 loan with an interest rate of 7.2%? Okay, so payment is the function. So payment, the interest rate is A8 divided by G8, or 7.2% divided by 12. Number of periods is 13 times 12. Present value is 100,000. The future value is minus 40,000, and that's sufficient. So it says minus 833, so I know that the cash got to leave hands of the borrower in the tune of $833.37 every month if they're going to make the balance go from 100,000 to 40,000 in just 13 years.